Okay, so this next type of quadratic formula problem, you're going to notice that the radical is going to need to be simplified, okay? So that's kind of the difference between this one and the last video. So we've got 4r squared plus 15r plus 7 equals -1. So again, our first step is to make sure it equals to 0. It's in standard form. So in order to do that, we've got to move the 1 to the other side of the equation. Okay, so if I do it on one side, I got to do it to the other on the like term. So I got 4r squared plus 15r plus 8 equals 0. My next step is to name the a, b, and c. Okay, so this time, or every time, it's ax squared plus bx plus c equals 0. So this time a is 4, B is 15, and C is 8. Notice that it was all positive because all of the signs were pluses. If there was any minuses, it would be a negative number, just so we know. And then the next step is to plug and chug in quad formula. Plug and chug in the quadratic formula. Okay. So you can either get this from your notes on page 58. You can look up the quadratic formula. It'll come up in Google really nicely. Or you can memorize it. So it's x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. Okay, now that I've got that, I just need to plug it in and chug it out. So I've got x equals the opposite of b, which is 15, plus or minus the square root of b, which is 15 squared, minus 4 times a, which is 4 this time, times c, which is 8, all over 2 times a, which is 4. Okay. Now that we got it plugged in, remember we like to simplify in 3 locations. Front is first. So we've got the opposite of 15. So the opposite of 15 is -15. Then I keep my plus or minus and my square root, and I simplify all of this stuff. Remember, my favorite way is Desmos. So if I plug that in, I've got 15 squared minus 4 times 8. And remember, I like Desmos just because I could see that I actually did it correct. I could verify this looks like that. On your cell phone, it's a little bit harder to do because it doesn't have the big memory on there. So 97, and it's all over my 2 times 4, which is 8. My next step is I take my square root and I take it off to the side and I simplify it. Okay, so I need to ask myself, what can go into the square root of 97 nicely, perfectly? Okay, and I want to use perfect squares only. So this is going back to the simplifying radicals. So I need to list my perfect squares. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100. And I could stop here because it's bigger than my square root. Okay. So if the 100 is bigger, I know it can't fit into it evenly, so it's off my list. Now I just need to divide these to find them out. So 97 divided by 81. Nope. 97 divided by 64. Again, that's a decimal. 97 divided by 49. That's a decimal. 97 divided by 36 is a decimal. Right? And I think 97 is prime. So I think these are all going to give me decimals other than 1. So let's just verify that. Nope, 25 is a decimal. 16 is a decimal. 9 is a decimal. 4 is a decimal. And of course, 1's going to fit into it, but 1 makes no difference. So I actually don't need to change this. And this is my final answer. Okay? The reason that that's my final answer is because then square root of 97 can't simplify. So if you ever are doing your perfect square list and the only number that can go into it is 1, it is not simplifiable. You are done with that problem. Okay, let's talk about how to type this in. A lot of students were having trouble typing it in because they were typing in the x equals. Delta Math doesn't like the x equals. So instead of doing the x equals, I'm only going to put in everything after the equals. So I'm still going to have the divided by first so that I can fit everything on top. Okay. So I do the whole top and then I put it over the 8 and I submit my answer and it was correct. Okay. And it tells you the exact same thing. The radical does not simplify. That's why we stop there.